Right, example 3. Water pours into a rectangular fish tank at a rate of 0.3 cubic meters per minute. How fast is the water level rising if the base of the tank is a rectangle with dimensions 2 by 3 meters? So we can go ahead and sketch a very basic representative tank here. You do not have to spend much time at all sketching these. I always prefer to sketch something just because it helps keep me on track. There we go. We're going to make this 3 meters by 2 meters. And we're going to go ahead and say that the water is right there. So this distance here we'll call h for the height. So h meters. So the actual amount of water in this tank, the volume of water, will be 6h. So then if we differentiate with respect to time, we'll get 6 dh dt. And we want to know how the water level is rising. So that's dh dt. So this is 1/6 whatever dv dt is. Well, we can go ahead and plug it in. In this case, it would be 1/6 times our dv dt, which is 0.3. Which this turns out to be, let's see, what is this? This would be 1/20 meters per minute. In the previous two examples we've done, we needed to not only plug in the given rate, but we also had a particular value that we needed to plug in. The previous example, we had theta equals pi over 6. We had to plug in addition. And the first example, with the ladder slipping down the side of the wall, we had to plug in y equals 4. Here in this problem, we only needed to plug in the rate, dv dt. There was nothing else. Why is that? Well, the reason in this case is because this water level rises at the same rate. It doesn't matter how much water is in the tank. Sometimes the rate of change depends not only on another rate, but also the current value of certain things. So ultimately, it's because of the geometry of this tank as a rectangle. If we had something like a conical tank, then the water level would rise very quickly in the lower half of the tank, but then the water would rise more slowly at the top of the tank because the geometry is different. The cross-sectional area, so if you were to slice this cone at different values, different heights, the amount of area is small here, but large up here. So it takes longer to fill it. So the reason why this doesn't depend on the h is because of the geometry.